So here I have a list of applications of geotechnical engineering. It may not be a very exclusive set of applications, and there are many more. The prominent ones are listed here. Applications of geotechnical, you can make it as a design applications, analysis, and we can talk about other fields. Design has got foundation. I have already told you what is foundation. It's a structure which transfers the load from any superstructure to the soil or ground or rock. Design of foundation means when you construct the road, obviously below the road there will be some soil, and this is also constructed with the soil many a times. Then that becomes what is known as pavement design. Deep excavations. In some buildings or structures, you may not find a good foundation material nearer to the top surface of the ground. In such cases, we have to dig deep, or we have to penetrate with the columns of concrete and transfer the load, right? Which we call them as pile foundations. Piles are nothing but pins or columns constructed below the ground level to transfer the load to proper foundation material. Or there is one more which is called as well foundation in case of bridge piers, etc. What is done is a big area is excavated for very deep depths, and then the construction is carried out. So such uh, foundations need excavation. So whenever there is a deep excavation, obviously there is a possibility that the soil will be caving in from the sides. So what is the kind of care one has to take? That study is covered under deep excavation, and the kind of foundation that we study there is a deep foundation. The other foundations are referred to as shallow foundations. Next is tunneling. In tunnels, you know that on the upper part of that tunnel will be having a huge hillock or mountain kind of thing, and we have to go through so that we can save a lot of distance, right? So for tunneling, obviously we should know what is the kind of material property like soil or rock that is present inside this particular proposed tunnel. Then foundation on difficult soils. Difficult soils is maybe the soil is not having a required strength of the foundation. Maybe it is possessing a lot of water in it. Maybe some kind of chemical is present. In all such cases, how to improve the properties of soil so that it is used in construction, or foundation is constructed above that. So ground improvement techniques are used for construction over difficult soils. Now analysis. Here, whenever there are maybe road embankments, or if you take earthen dams, earthen embankments, so this is a structure which is built with soil, which is an earthen dam, and the water is standing on the other side. So you should be able to analyze this slope and then find out how safe it is. What is the factor of safety of this? If not, then what is the kind of slope to be given so that it will be safe enough? So analysis of embankments, whether it is a earthen dam or even road embankments or some other embankments are there, then how to safeguard the people and how it can be designed. That is what is part of it. Rather than design is here analysis is important because natural slopes will not be constructing anything but how safe it is, and then man-made slope when it is there how safe it is. Our design is nothing but providing a good slope so that it doesn't cave in or doesn't flow off. Next is excavations. So whenever foundation is done, you have to excavate, right? But in case of foundations of bridges and piers, bridge piers, there is what is known as well foundation. Now in such cases, we have to do the excavations below the ground level, and then sometimes it is not possible to do it in open environment, so there will be some kind of cover that is provided, excavation is done, it will be removed. Even in case of tunneling also, when it is excavated, obviously there is no ventilation as such. So what are the techniques to be used and how that material has to be brought out? There is a big science behind that. Because without ventilation, it is a big problem because there is a lot of dust and people who work need oxygen. So it is a difficult task, so to say. Next is analysis of underground structures. Just now I told you that hydroelectric power plants have got many of their hydel stations below the ground level. Power generation power plants are below the ground level because of safety. So when you want to construct the buildings like that, obviously you should know the forces coming on the structure and how to safeguard our structure against those forces. Forces are because of soil. So how the soil behaves on the surface of the structure matters a lot. Next is retaining structures. Retaining structures, there are a number of examples. The simple one over here, I have a rock retaining wall. It is retaining the soil on one side. Maybe here there is a natural slope and then they have made a road here. To take care of the road, they have constructed some retaining structure. Even in this case also, there is of course soil and rock that is present. This structure and even this structure is holding the soil behind, so these structures are known as retaining structures. They may retain earth. Most of the times it will be retaining earth. Sometimes when it is retaining water, it is called as dam, or in some cases it is a mixture of soil and water which will be behind the retaining structure. So to design the retaining structure, we should know what is the kind of force that is coming on the retaining wall. So that kind of analysis is studied in geotechnical engineering. Other fields of concern are environmental geotechnics, earthquake geotechnics, and ground improvement. There are separate specializations in these fields. So environmentally, how the ground should not be disturbed, or how we can take the use of the ground itself for improvement of environment. This is what is studied in environmental geotechnics. Then earthquake geotechnics. Because of the earthquakes, there are a lot of changes in the surface of the on the surface of the earth because of the tectonic movements. But how the soil behaves exactly during the time of earthquake, that is what is earthquake geotechnics. Ground improvement techniques. If this ground is not strong enough to sustain the load of the structures, in such cases we have to improve the properties of the ground so that we can build whatever structure that we are planning. Right? That is about different applications of geotechnical engineering.